What's the difference between data-driven and AI-driven?
That's a really good question, Eric. So I'm actually going to answer that. So the difference, if you just go back to like the data to impact loop, right, which I sort of came up with like 2 or 3 years ago, it basically states that today everyone is talking about data is the new gold. Still, I don't believe that I don't believe that to be true at any given point in time. And the reason being is that today data has to be turned into information. Information needs to be turned into insight. Insight needs to be turned into action, and action needs to be turned into an outcome or an impact, right? And the problem, if you look at the smart building space or the dumb building space or the real estate space in general or traditional industries, that data exists everywhere, right? But it's really hard to get to. And it's not that easy to turn data into information, either for other people or for other systems or for AI. So those are the three things also I want people to understand, that whatever you do, you need to take this data and make it valuable, not only for different people from different industries, but also from different systems from different industries, and also for AI. So again, if you look at that, taking data to information and then information to insight, that's not really easy. And insight into action is not that easy either. And you go through that step, and usually what happens is someone gets stuck somewhere. They never realize the value. They never realize the impact or the outcome. And this is especially true, I think, like in the smart building space historically, because you do a lot of predictions, you do a lot of analytics of what might go wrong or what is going wrong or all this kind of stuff. But is the impact realized? Or what do you do in order to do that, right? Well, we need to contact someone, or we do some more PID loops, or we get people out with a wrench, or whatever that can be. I think that's again with the difference with the project that I've been involved in now in the last 2 years, as in we want to create this, what Ken Sinclair, whom I absolutely love, honestly, he's my idol.
He's great.
Making buildings aware of what they need to be aware of, but also making buildings, be able to have the capabilities to not only be aware of stuff, but actually solve the problems that you made them aware of, right?
Yeah.
So again, to have that local control and also the actuating capabilities, like I mentioned before, you don't need to go to the cloud, right?
Right.
You're making the buildings themselves are becoming aware of what they need to be aware of. And they're actually, self-learning and self-actuating on it, right? So again, the difference between then the data-driven strategy as well as the AI-driven strategy is that if you work with AI and have that as an AI-driven strategy, you have to know and understand what do we need to do in order to make it easy to work with AI. So AI today is magic, obviously, like everyone knows,
Right.
but it's also more than that. It's actually data scientists,
Yes.
or AI engineers, or ML engineers, or machine learning, and all this kind of stuff that needs to understand the context which they're trying to improve. Again, where does the data come from? What are we supposed to do with it? Is it tagged? Is it standardized? All this kind of stuff.
So,
and in order to do please.
No, what I was going to ask you, so if I'm understanding correctly, would an example of this be something like, on one hand, so, building gets commissioned, everything gets calibrated, right?
Yep.
One level, you get the data that the temperature is not controlling right or whatever, and somebody comes in and recalibrates the system. What I hear you saying, I think, is that, well, instead of having somebody come in and recalibrate the system, the building becomes aware that it's out of calibration and sends out an algorithm and recalibrates itself. Is that?
Yeah.
Okay.
That's what we're doing already. That's what we're doing right now. Yeah.
But is that sort of a very simplistic example of what you're saying needs to happen at a much larger scale?
That's part of it. But what I'm aiming at is more that, okay, if you understand sort of, again, you have an existing building. You have like traditional controls or not even any controls, whatever that might look like, right? Then understanding, or like let's say you have some controls done. And if you start with a data-driven strategy, usually you want to, people look for where is the data today, right? And they don't look at, where the data is in people's minds. They actually look at the data. Then they find out, well, it's stuck, right? And some kind of tool, Niagara or Johnson Controls or Siemens or a combination of everything. And maybe it's an old building. right? So maybe it's backing at MSTP, or it's Lawnworks, or whatever that might be, or it's pneumatics, or anything and everything. So starting at technology first, which again, like I don't necessarily believe in, and just looking at, first like a people perspective, understanding that actually people are going to work with this. Whether that is a user that needs to explain what they're after, or it's a technical asset, integrator, or it's a data engineer, or it's a decision maker, or it's the CFO or the CEO. It's actually people that use AI because it's a tool or it's a methodology or whatever it might be to get the job done, right? So, and again, it goes back to the digital twin. So you have like the 3D representation of reality as the collaboration arena. That's number one. And the reason why that is important, I can just explain briefly because of these schools, right? Because when we just got the data from the schools and, we saw how the building was used, some of the designs you couldn't really figure out, why is this happening? Right? Why is it getting warm? Why is it getting cold? And we can then, with the digital twin, we can see that the sun is, coming in at different angles.
Yeah.
Right?
Okay.
And if you just look at an Excel sheet, and again, without any adherence to what the layout is, even with the building, it's really, really hard. These problems you can get stuck for months trying to figure this stuff out. Yeah, make the correlation. Or, the ventilation comes on, or all these kind of things, right? Whereas if you have the 3D model where you can actually ask the user or ask anyone, why is this happening? And again, like, with the digital twins that we have, we tied it to where it is in the world. So we simulate, how the sun is moving, correlate that with weather data and all this kind of stuff. It's just like makes it easier for data scientists to understand the context and, interpret the data in a way that anyone and everyone can understand. So again, like, so the difference is, it's a lot of differences, but, starting with AI-driven journeys, you have to understand that from a data perspective, the data also has to, of course, be tagged. And if you're looking at the, the industry of smart buildings, Haystack, Brick Schema, maybe Real Estate Core, or at least have some way or a structured way of, exporting the data so that other systems would make sense of it, right? But again, what I like with Haystack and Brick, it's also like the spatial context of that fact as well, that you not only start understand, the data passport aspects, where it's coming from, but where does it actually originate from in the building, right?
Yeah.
And if you combine that, structured tag data with then a 3D model that would make it easier to turn data into insight information for people, that's all like, those two things that are needed in order to get data scientists to work with other people and get this stuff done. And once you also have that, really rich data pipeline, and then it's bi-directional, and if it's also tied to actuating, and I'm basically spilling the beans here on everything, but it's sort of, I want to get this done, right? That means that you can also run this, more auto GPT and like automatic, strategies.
Yes.
That basically reality is the teacher. No more guesswork.
Yeah.
No more just PID loops or recalibration or whatever that might be. You actually, the building is teaching itself based on its usage, and then of course with informed, decisions by its users or whatever that might be. But actually to self-learn, self-correct, predict, and do all these kind of things, right? And that goes back again to decarbon solutions. Again, getting this in, right? The box, the Meta Cloud server, in this, connected to a lot of different things, get rewarded for the amount of energy that you're saving. Maybe do automatic ESG reporting, right? And that basically solves like, energy efficiency. You solve like the maintenance aspects. You solve a lot of these problems. And you actually, again, doing what, automated buildings should be about. It's not about building automation. It should be about automated buildings. And not just the HVAC side, not just the energy side, but the building itself should have a higher degree of resiliency, efficiency, and we need to make the building smarter, not just applications or vendors or products. The building has to be smarter.
So you're talking about fixing the whole versus trying to fix the parts.
Yeah, 100%.